think back long ago to the days of geometry and right triangles. And back in the day, you probably looked at special right triangles that had special properties to them, and you were asked to memorize them. And so you did, maybe, for the quiz or the test. And then you haven't really thought a whole lot about them since then. But in trigonometry, the study of triangles, we are going to be using the special right triangles. Lots and lots. So let's go back over it, okay? And we realize that this started with Pythagoras. Pythagoras was a philosopher and mathematician long ago, you can tell, although beards are back in style now. And what we remember from him, and most everybody remembers from him, is his theorem. A squared plus b squared equals c squared. All right? And so in a right triangle, and it has to be a right triangle, this does not hold, this theorem does not hold in any other kind of triangle, no obtuse or acute triangles, just the right triangles. And what we mean by this is that the long side, the hypotenuse, right, and we call that C usually, and then the legs, this is leg 1, this is another leg, B, right, that the sum of the squares of the legs equals the square of the hypotenuse. So C is always the longest side. All right, so all of this has to go back to Pythagoras and the Pythagorean theorem. So the first type of right triangle that's a special right triangle is a right isosceles triangle. And in a right isosceles triangle, the legs are congruent. Okay, so on this triangle, 45, 45, 90, because we know, why do we know those are 45? They're the same, but we know that all the angles in a triangle add up to 180 degrees. And that's just its definition. So that's how we know. All right, so we know that the sides are also related to each other. But if you're like me, I have to think about it a minute. All right, so here's an example. This would be side A, this would be side B, and this would be side C, right? So the Pythagorean theorem says C squared is equal to A squared plus B squared. All right, so let's let A and B be the same number, whatever that might be. Okay, so let's let it be 1. So we would say that C squared is equal to 1 squared plus 1 squared, which is 2. So then C would be equal to the square root of 2. Let's try a different one. Let's let A and B both be 4. 16 plus 16 is 32. So C would equal the square root of 32, right? 32 is 16 times 2. So that would be 4 square root of 2. Okay, so what did we notice here? Well, we noticed a pattern. Remember, math is all about patterns. That A equals B equals 1, and this became the square root of 2, or 1 times the square root of 2. A equals B equals 4, and then this became 4 square root of 2. So the ratio on this would be, if this is 1 and this is 1, this will be square root of 2. Okay? So, all right, that's the ratio. So if I told you A was 3, then you know B would have to also be 3, and C would be 3 square root of 2. You see the pattern. It's all about patterns. And that's awesome. But what if I tell you that the hypotenuse is 1? The hypotenuse is 1. Okay? Now, almost if you Google it, I dare you to Google it, if you Google right triangles, 45, 45, 90 right triangles, count how many are in this orientation, right? But I need it in this orientation. I didn't want to draw it because it's hard to draw to make it exact. So I flipped it over. That's why these are backwards. So I just flipped it over, whatever. Okay, so change the orientation on it, but now this is 1. So that means 1 squared is equal to A squared plus B squared, right? So 1 equals, A and B are the same, right? They're the same. So I could say B squared plus B squared. So 1 equals 2b squared. B squared is 1/2. B squared is 1/2. So b has to be equal to the square root of 1 over the square root of 2. Okay, so what that means is the ratio for this one is 1 over square root of 2, 1 over square root of 2. Now remember rationalizing denominators, right? So this 1 over square root of 2 would be 2 over the square root of, or excuse me, square root of 2 over the square root of 4, which is 2. So this is the same thing as square root of 2 over 2. Now, here's the deal. Here's my question. Is it always this? If the hypotenuse is 1, is this side always square root of 2 over 2? And if this side is square root of 2 over 2, is this side square root of 2 over 2? Does this ever change? No, it doesn't. So something that never changes is a really good thing to memorize. And this right here, this triangle, would be a good thing to know. But we're going to reinforce it. We'll make it easier for you to memorize it. But this is the ratio that's important. So on the next, the right scalene triangle, the 30, 60, 90 triangle, you could do the same thing with the Pythagorean theorem and prove to yourself these ratios. And I encourage you to do that if you still don't believe me. But in order to find the ratios on a 30, 60, 90 triangle, we would let the hypotenuse be 2, just an easy number, right? And then the side opposite the 30 would be half that. Half of 2 is 1. And the side opposite the 60 would be whatever this side is here times the square root of 3. And that ratio holds no matter what the hypotenuse is. So for instance, if I had a right scalene triangle and this is 6, the side opposite the 30 would be 3, and this would be 3 square root of 3 every time, right? Just like you did 45, 45, 90. Now, what we're going to use this for, almost exclusively, is where the hypotenuse is equal to 1. So let's work it backwards, or do it the same way, right? If the hypotenuse is 1, the side opposite the 30 is 1/2. The side opposite the 60 is square root of 3 times the side opposite the 30, which is square root of 3 over 2. Now on this bottom triangle, I've changed the orientation again so that it's 30 down here at the bottom. Doesn't matter. The hypotenuse is 1. The side opposite the 30 is half. And the side opposite the 60 is square root of 3 over 2. Once again, does this change? No. So it's going to be worthy of a memorization. But we're going to work with it over and over and over so that repetition will naturally help you memorize. And you're going to be really familiar with these values. So once again, let's do this again. If our hypotenuse is 1, the side opposite the 30 is 1/2. The side opposite the 60 will be square root of 3 over 2. In a 45, 45, 90, if the hypotenuse is 1, the legs will be square root of 2 over 2 and square root of 2 over 2. Now, I threw this one in. Does anybody, I wonder if you know what this is. Since these are all three, the 3, 4, 5 triangle is called a Pythagorean triple. And this is how carpenters lay out to make sure that this is a right angle. If you go 3 feet this way and 4 feet this way and make sure this is 5 feet long, this will be a right angle. It'll be perfectly square. But it's a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. And then also the multiples. So if you multiply through, if you did 6 and 8 and 10, that's a Pythagorean triple. If you multiply through by 3, that's a Pythagorean triple. Another famous one is, well, this one's probably more famous, 5, 12, 13, 7, 24, 25. The Babylonians made tablets of these, clear up into the 3-digit numbers that work out. They're just kind of cool. But if you remember some of them, it makes things a lot easier. One last thing. You know that a unit circle is just a circle whose radius is 1 unit. Now, this tiny little circle here has a radius of 1 unit. This even smaller has of 1 unit. Okay? Now, the 1 unit on this one might be equal to 4 millimeters, right? But it's still a unit, all right? So that's all that means. So what I've done on this last one, we're going to work with this back in class and do a discovery. This will be really important. But I want you to see the orientation of the triangles, the right triangles that I put on here. These are special right triangles. Notice that they have a vertex on the center and that their side lines up with the x-axis, not the y. This is the x-axis, this is the y-axis. So it only lines up here. And so your angles are in the middle. And then you can see. So if this is the radius, right, this is 1, then the side opposite the 60 is going to be square root of 3 over 2. And the side opposite the 30 will be 1/2. And so all of this is related. So I hope you took good notes, and please write down any questions that you have about special right triangles because we're going to be using them in class.